going to look in this video at how we how we take a bearing using a compass. On this map extract that I've got in front of you here, we've got point A and point B, which are connected up, I know, by a motorway, but it's the easiest standout part of the map without it being one of the pathways that we might be using in any of our future walks or expeditions. It's also at a nice angle for us to measure. Before I even start to think about taking my compass out though, what I need to do is look at point A and point B and try to guesstimate the angle that point B is away from point A. Now the grid lines are running, there's one running there, north to south, there's one running there, north to south. We always count, we start from north as being 0 on our when we're measuring bearings. So just move that around so that it's, I think that's slightly better. I would, before I take the compass out, I would guesstimate what the angle is, what the bearing will be. And if north is there and I'm measuring from north, then B looks to me to be around about a right angle. It looks to me like it would be about 90 degrees away. Now we'll check that using our complicated piece of kit, the compass. We do that by laying the compass on the map and putting our straight edge, again one of the points that I referred to when we looked at the anatomy of the compass, on there. Just twist it out so it's slightly more on. Okay, so I've got the straight edge is connecting up point A there with point B over here. Now I'm going to hold that in place on the base plate. What I also need to do at this point is just make sure that running through the centre dial of, the central part of the dial, I've got a grid line, and there is one there which I'm just tracing with my finger running from north to south. That is going to be extremely important to me, because when I now rotate the dial, I need to make sure that these lines that are printed on the bottom of the dial, which move when the dial moves, I need to make sure that they are parallel with the grid line. And now they are. There's the red line there and the red line there. You might not be able to make this out on the video, but there is a grid line that is parallel midway between those two lines. It carries on down there. Okay. What I now need to do then is measure the reading, and if you remember from the previous video, I mentioned about this little notch that is printed underneath the dial. As I spin the dial around, you'll see that that notch, that black notch, remains there where it is. Let me just move this back now so it's parallel, and it is. And I'll take my reading from there. Now in this case there's 80 degrees there, there's 100 degrees there, and yeah, by my reckoning that is bang on east, that is bang on 90 degrees. So I've guesstimated 90 degrees, and I've also now got 90 degrees measured by the compass. Ordinarily we might have to add or subtract a few degrees to that, depending upon the magnetic declination. Now that's quite complex physics. Basically what I will do later on this year is I will tell you what we need to add on and what we need to take off, because it changes every year. It's the basically it's the difference between magnetic north, which we're using here with the compass, and grid north. Okay, so we've got an angle of 90 degrees, we've done that bit. Now this is where the compass becomes more than just a protractor, because if I now rotate the entire compass without touching the dial until this red arrow here and this red floating needle here are pointing in the same direction, which they are now doing, the direction of travel arrow here tells me that in reality that is the direction that I actually would need to be walking in if I was currently at point A and wanting to walk to point B. So this is where the direction of travel arrow, which I said before is quite an innocuous, almost irrelevant looking little arrow, now becomes very, very important, because that is pointing to me the way to go.